The year is 2035. Elon Musk's dream of a city on Mars is no longer a dream. The first ship has landed, a single foothold in a new world. But this is just one ship on a dead planet. The ship is not a habitat. It is a construction kit, packed with an army of robotic builders. The first worker sets foot on Mars, an autonomous rover, ready to begin the most ambitious construction project in history. Running on its own power, the rover's mission is to build a power source for everything else. Its first task, to deploy the main power grid, a massive, flexible solar array.
The initial power comes from the sun. These are thin-film, flexible solar arrays, designed to be unrolled like a carpet.
A team of 2 is needed for the first deployment, a synchronized mechanical ballet. To connect the team, a tether is fired, a crucial link across the Martian soil. A perfect catch. The 2 rovers are now connected, ready to begin the great unfurling. Unrolling the solar farm, a 100-meter-long sheet of high-efficiency photovoltaic cells laid directly onto the Martian dust.
This thin-film material is less efficient than rigid panels, but its advantage is density. You can pack kilometers of it into a single starship.
Anchoring the array to the surface, protecting it from the thin but powerful Martian winds. And the first power flows, a trickle of energy captured from a distant sun. Day after day, the rovers expand the farm, creating a multi-acre power station with relentless efficiency. The result, a 10-acre solar farm built entirely by robots in under a week.
5 megawatts, enough power to run a small town. A major engineering success for the first phase of construction. But it's not enough. To create fuel and air, the base needs a chemical refinery. And that refinery is a monster.
The first Great Wall, the solar farm, as massive as it is, can't provide the industrial power needed to build a city. The solution arrives on the second ship, the heart of the permanent power station. A new kind of power plant, designed for the harsh Martian environment. The answer, nuclear, a small, simple, and incredibly reliable fission reactor.
This isn't a complex water-cooled reactor. It's a kilopower design, a solid block of uranium system.
The design uses a heat pipe, a simple and robust technology to transfer the immense heat of the core. That heat drives a Stirling engine, a simple piston that has been used for over 200 years. And the piston moves a generator, creating a steady, reliable flow of electricity. But a nuclear reactor needs to be shielded. The first step? Dig a hole. The reactor is lowered into the ground. The Martian soil itself will be its primary shield. Buried deep beneath the red sand, the reactor is safe and secure. A lifeline of power, connecting the nuclear heart to the growing base.
With the problem of power solved, the real work can begin. Now, they have the energy to build a civilization.
And the temperature swings are extreme, a 100-degree drop every single day.
You cannot live on the surface. The only way to build a permanent, safe city is to go down.
The solution arrives on the third ship, the primary tool of Martian construction. A next-generation tunnel boring machine, designed by AI, built to conquer the rock of Mars.
This isn't just a drill. It's a subterranean factory on wheels. It digs, removes the debris, and builds the finished tunnel.
The digger is assembled, a 100-meter-long subterranean machine ready to carve out a new world beneath the surface. To begin, the TBM needs a launch pit, a massive trench dug to position the machine for its first cut. And the great work begins. The first cut, the start of the first Martian main street.
Boring on Mars is different. The low gravity is a challenge. This machine uses these hydraulic grippers to brace itself against the tunnel walls.
A continuous process. The machine grinds the rock at the front and expels a steady stream of debris out the back. An automated train carries away the excavated rock, keeping the path clear for the advancing machine. And as it moves, it builds. A robotic arm erects concrete segments, creating a perfect finished tunnel as it goes. The first street of Mars Base Alpha is paved. 100 meters a day, a relentless march under the red sand. But a concrete tunnel isn't airtight. To create a breathable habitat, you need a perfect final seal.
The solution is a new kind of sealant, a two-part epoxy mixed with Martian dust. It foams up to fill every microscopic crack.
A spray-on sealant made from the Martian dust itself. It seals every joint, every crack, creating a perfectly airtight environment. The first habitable space on Mars is created, a shelter from the wind, the cold, and the deadly radiation. The tunnels are the streets, but a city needs rooms. The TBM carves out massive underground caverns, the future homes and laboratories of the base. A hidden city takes shape, a network of tunnels and caverns, a new home for humanity, safe beneath the sand. The first section of the city is sealed, and for the first time, a human-breathable atmosphere exists on Mars. With the air on, the interior work begins. Robots furnish the empty tunnels, turning them into corridors.
Creating a breathable atmosphere is just the start. You have to constantly scrub the CO2 and circulate the air.
And then there was light. The first Martian sunrise deep beneath the ground. A new road on a new world, paved by machines for the humans who will follow. The city expands, creating junctions and side streets, a growing subterranean network. And creating exits, a network of tunnels connecting the underground city back to the surface world. Connecting the levels, the first Martian elevator linking the city below with the sky above.
The design is redundant. If one tunnel collapses or is sealed, there are always at least two other ways to get between any 2 points in the city.
And on the surface, almost nothing has changed. The true scale of the construction is completely hidden. A shelter is built, a fortress against the void, a promise of a new home. A city built entirely by machines, a new kind of construction for a new kind of world.
This is the most important factory on Mars. It's not making fuel, it's making food. It's the difference between a temporary outpost and a permanent city.
And with the city built, the robotic army rests. Their monumental task is complete. The factory has done its job. The city is ready. But the true scale of Mars Base Alpha is hidden beneath the dust. A stunning reveal. A multi-level radiation-proof city. A hidden jewel beneath the red sand. The main streets of Mars. Clean, pressurized, and ready for life. And the green heart of the city. Farms, powered by nuclear energy, growing fresh food under a synthetic sun. A home, waiting. Every system green, every resource abundant. And the final arrival, the most precious cargo of all, humanity. A new dawn, a new world, seen through human eyes for the very first time. The final touchdown, bringing humanity to its new home. And the first human steps, not just on Mars, but into a city built by machines for them, walking towards the airlock, the gateway to a new civilization.
The first city on Mars wasn't built by human hands. It was built by an army of robots, as a testament to human ingenuity.
A new home, forged in the red dust and powered by dreams. A new light, shining in the darkness. A new future for humanity on another world.
To see what they build next, subscribe to Next Gen Manufacturing.